Now, if we look at the distance, by definition, the distance is measured is a measurement of the length of the path from the initial point to the final point. Okay, it is the length of the path. So, by definition, the displacement, the distance is a scalar. We don't care, or there is no meaning about the direction of the distance, but the displacement is a vector. So we have the displacement is a vector, while the distance is a scalar. There are many scalar and vector in physics. The velocity is a vector. The speed is a scalar. Later we will learn about many quantities like the force, momentum, torque, and many quantities, and we have to specify both magnitude and direction to those quantities, so they are vector. But some quantity like temperature, like the mass, like time, and many more quantity that we just specify the magnitude, and those quantities are scalar. In general, when we talk about the scalar, we just give the symbol to that quantity. But for vector, we will use this symbol. For example, if I want to write down the vector A, I will use the symbol or letter A and have an arrow above the letter, and this is a symbol for the vector A. In some text, they may write the letter with the boldface and no arrow above. But in my lecture here, if you type it like in the book, you can both use the letter, the boldface letter, and the arrow above, or just the boldface letter. But if you write by hand, like when I prepare the script, I will use the letter and the arrow above. Okay, so this is a symbol for the vector. Sometimes in this chapter we will study also some special kind of vector which we may write the hat above the letter for the vector, and we always use this for the unit vector. We will discuss about this unit vector soon in this chapter. Now, let's discuss some basic properties of vector. First, we have to define the equality of two vectors. Two vectors are said to be equal if they have the same length and point to the same direction. As in this figure, you can see that these four vectors are equal because they have the same length and they point to the same direction. Note that they don't need to be at the same position. Okay, obviously you can see this in this figure. These four vectors start from a different point, but we can say that they are all equal. So we have the condition. We have the condition for equality as same length and same direction. Okay. Next, adding vector. The easiest way to show the adding of two vectors is to represent it graphically. In this figure, you can see that adding two vectors is to join them head to tail. Okay, we have the vector A and we have the vector B, and we want to add A and B. So we put the tail of B at the head of A, and we draw an arrow from the tail of A to the head of B, and we define this as the result of A plus B. Okay, as a result of A plus B. We use this method, the head to tail method. Okay, this is a head to tail method to add two vectors. When working with vector, one thing that you have to be careful that when you add two vector, don't forget that when we add two vector, we have to use the head to tail method. We cannot just add their magnitude together, because we have to take care the direction of the vector too. So when we add the vector A with vector B and we set it equal to the vector C, it is very different from adding the number A and B and take it equal to C. The first equation is a vector sum, which must be handled carefully, that with the graphical method, as we already discussed. The second equation is a simple algebraic addition of numbers that is handled with the normal rule of arithmetic. Okay, so this is one point that you have to be careful when working with vectors. And if you want to add more than two vectors, you can also use the head to tail method. is the head to tail method. Okay, to add, in this case we add 4 vector A, B, C, D, and we use the head to tail. We put the tail of B to the head of A, tail of C to the head of B, and tail of D to the head of C, and we draw the arrow from the tail of A to the head of D, and that is the result of A plus B plus C plus D. The vector addition follow the commutative law. It is obvious from this figure that if we say R is equal to B plus A, so this is B and this is A, so we have B plus A, and it is obviously that we can say that R is equal to A plus B too, so this is A and this is B, so we can change the order of the addition, but we get the same results. So we say that vector addition follow the commutative law. The vector addition also follow the associative law. In this figure, you can see that if we want to add A and B and C, we can group by adding B and C first. So this is B and this is C, and we add B and C to get this vector first, and then we add this with A, and we get the result of A plus B plus C. But we can do this by the different group. Here we group A and B first, and then we add it with C. So we have A here, and we have B here, and we have A plus B, and then we add it with C like this, and finally we get A plus B first, and then plus C, and the results from the first method and the second method are the same. So we can say that we have A plus B plus C. Add B and C first is equal to A plus B. Add A and B first, and then plus C.